Let us do example number 4. For the function g of n is equal to 2n minus 7, determine n. So I'm going to determine n for 2n minus 7. A, g of n is equal to 11. Really, g of n is our output, and look at g of n is equal to 11, and g of n is this. Equals really means is. So what, instead of writing, g of n is equal to 2n minus 7, I'm going to plug in 11 instead of g of n. And what we'll notice is that the unknown variable that is left is n. So simply, I'm going to solve this. I'm going to add 7 to both sides. Divide both sides by 2. N is equal to 9. And if you want to test it out, 2 times 9 minus 7, well, that's going to be equal to 11. B. I always like to write out my function. G of n is equal to 2n minus 7. I know the value of my function g of n, and that is negative 6. So I substitute negative 6 for g of n. So negative 6 is equal to 2n minus 7. I'm going to isolate for n. I'm going to add 7 to both sides. I'm going to divide both sides by 2. And I get n is equal to 1/2. Now I have this notation business is just really wrapping your head around it, and it is really, really useful, particularly in grade 11, 12, and physics. So if you're planning on taking the sciences, this functional notation really is the way to go. For the function h of w, is equal to negative 4w plus 2, determine w, right? So we need to determine w. So I have h, I'm going to write h of w is equal to negative 4w plus 2. What I see is the value of my function is 50. So I'm going to substitute h of w as 50. So 50 is equal to negative 4w plus 2. And then I'm going to, I am going to solve for w, subtract 2 to both sides, divide both sides of the function by 2. So I get w is equal to negative 12. Similarly, I would do that for